Hello everybody, it's Mr. Takahashi here. This question came up on Friday and I thought I'd do a quick little video about it because I do not believe we talked about it. And there might be a number of you that might have this question about the buffer system. This is the carbonic acid buffer system. This is the one that we talked about that exists sort of in our, well, one place is in our blood. This helps to maintain a certain pH, and we all understand why it's so important to keep a certain pH. pH is all dealing with acidity, or if something is basic, if it starts to drop below 7 or it starts to get lower, we're becoming more acidic. If it becomes higher or above 7, it becomes more basic. And while we're on those two terms, let's just remind ourselves of how we in biology look at or define something that is either basic or not basic, or something that's acidic or not acidic. This is what we define as an acid. It's a substance that produces hydrogen ions when dissolved in water. And if we're talking about something that's basic, it is something that produces hydroxide ions when it is dissolved in water. All right, so those are the biological definitions that we're using for an acid and a base. So how does this apply to this system here? Well, this is our equation. There's our carbonic acid, but this is just an intermediate step. This will either go in this direction or in this direction. It can go either direction, back and forth. And carbonic acid will either dissociate into carbon dioxide and water, or it will dissociate into the bicarbonate ion and hydrogen ions. And like I said, this can go either way. So just as easily, the hydrogen ions and bicarbonate ion can form carbonic acid, and then that can go on to form carbon dioxide and water. Again, reversing it the other way, carbon dioxide can combine with water to then form carbonic acid, which would then go ahead and dissociate into those two ions there. So you can see that this can go in either direction. Now, how does this help to maintain a certain pH? Well, let's set up a situation where we have a low pH in our blood. Now, using our definition here, that means that we have, or should have, a lot of hydrogen ions floating around in our blood. This is the reason why this blood is considered to be moving towards acidity or dropping in that pH. So let's say we've got a situation where we've got a lot of these hydrogen ions floating around. What's going to happen is that this buffer system will take those hydrogen ions and start to do something with it. It will take hydrogen and combine it with the bicarbonate ion there and start to produce, let me just move this, it will start to produce carbonic acid. And like I said, carbonic acid doesn't stay carbonic acid for long because it will dissociate into carbon dioxide and water. And so what ends up happening is that this hydrogen here, which joined up with the bicarbonate ion, then becomes carbonic acid and then moves into turning into water. And just imagine this system basically using that set of reactions there to do exactly that. And you can see I'm purposely dragging these hydrogen ions on top of here to show you that this H is now this H that is part of this equation, because that's where it's going to join up with the bicarbonate ion and form carbonic acid and then dissociate into CO2 and water. And you'll notice as I'm doing that, I'm slowly getting rid of these hydrogen ions, and basically what I'm doing is I'm making it less acidic. I'm sort of counterbalancing that. We had this huge amount of acid or acidity here in the form of hydrogen ions, and we were able to use it up in this equation by simply having it go through this set of reactions to then form water. And we basically are just using up the hydrogen ions. Okay? But what happens if it is too basic? And like we said a base is a substance that produces hydroxide ions when dissolved in water. So let's say we have a situation where we have a lot of these guys here. All right, I'm just resetting this. Here we go. So we've got a situation where it is very basic. What's going to happen is this buffer system, this carbonic acid buffer system, is going to go in the opposite direction, because what it's going to do is if this is too basic here, meaning we've got a lot of hydroxide ions here, it's going to help try to neutralize the base by producing an acid. And again, what we define as an acid is anything that produces hydrogen ions. And in fact, that's a weak acid there, so it's going to produce hydrogen ions. Well, how is it going to do that? It's going to basically take this reaction and take some carbon dioxide, some water, create carbonic acid, and start producing these ions here. And what ends up happening is, much like we had the hydrogen ion sort of, there's two hydrogen ions there that we would have as part of water, what's going to happen is that these hydrogens from the water are going to go combine with CO2 and create this carbonic acid. Then it's going to dissociate and form these ions, and we now have an acid combining with the hydroxide ions there, the base. And this, what I'm trying to illustrate here, is the neutralization that's taking place. This is now trying to take the acid, combine it with the base, and you're now creating a salt and water. Now, I'm not showing you that process there, but that's how this system is able to neutralize or help to decrease the amount of hydroxide ions that are now in the blood, because this is now a situation where we have a pH that's high, or a basic type of scenario or situation in our blood. And it basically, again, neutralizes it by creating hydrogen ions. And how it does that? Take some water, take some CO2, form carbonic acid. Carbonic acid then dissociates quickly into these ions here, and now what you start to notice is that this acid starts to neutralize the base. So this step here is now going to involve some neutralization. But again, I didn't get into that part. We're just talking strictly about this reaction here, this buffer system. And let's just complete this, shall we? Hydrogens forms carbonic acid, dissociates, and I'm pairing these up just to show you that this is now going to neutralize the base. Here we go, and there it is, carbonic acid, dissociate, yay, there it goes. And I actually drew an odd number of this, but just imagine it was paired up with another through here. There it is, and voila, you end up with base that is now neutralized because you've produced an acid, and that then produces hydrogen ions, which can then go on to create water that, through the help of the hydroxide ions there from the base, you neutralize the base. This is how the system works. It's basically, you're either going to see it move in this direction to help counterbalance a situation where it's too basic, or it's going to move in this direction to help use up those hydrogen ions when you have a situation where it is too acidic. I hope that helps.